Simplifying radicals is something that you are going to use in every level of math from this point on. So it's important to try to get comfortable with it. And the reason why we simplify radicals instead of typing it into our calculator is that it's a much more precise answer. Just like using a pi symbol versus using 3.14, pi is a much more accurate number. Same thing with taking a square root of something that's not a perfect square. We're going to simplify it as much as we can, and we're going to leave it like that. And it's going to make us more precise than if we typed it into our calculator, which I think that's counterintuitive to some people. So let's talk about the idea behind a square root. We all know that the square root of 4 is 2, right? And we're just going to assume that we're only talking about the positive roots. And the reason that we know that is because 2 times 2 equals 4, right? Now, if I take 4 and I break it down into 2 and 2, that's a pair of 2's, and I'm going to circle that. But do you see how only 1 2 comes out? That's because that's the number that times itself equals 4. Now, we're going to be breaking down numbers, and sometimes we're going to have multiple pairs. But for every time we circle a pair of numbers, only one of that number comes out of the radical, because what that means is that that number times itself would be inside the radical. So let's take a look at 40. So 40, if I break that down, and it really doesn't matter if I do 20 times 2 or 10 times 4, 8 times 5, we're going to end up with the same thing. So let's just do 10 times 4 because it's simple. 10 is 5 times 2. 4 is 2 times 2. Now, I'm only dealing with the bottom level of this tree because I'm not going to deal with 10 anymore because I already broke that down into 5 and 2. I'm not dealing with 4 anymore because I already broke that down to 2 and 2. So what I'm going to look for is a pair of the same exact number on the bottom rung of this tree. So I see a pair of 2's right here. 5 and 2 don't have a pair. So we're not going to include those outside the radical. I'm going to draw my radical. 5 and 2 are both going to stay in there. They're going to multiply by each other. But 2 times 2 is 4, and 4 does have a perfect square root, which is 2. So I'm just going to put that 1, 2 outside the radical. Now, if I go and simplify this, the 5 and the 2 multiply. They remultiply to get back to a 10. And simplest radical form of the square root of 40 would be 2 square roots of 10.